Imagine a future where vast fortunes are forged in the depths of space, where a single asteroid holds enough precious metals to dwarf the entire Earth's economy. Join us on an extraordinary journey as we unveil the tantalizing potential of asteroid mining, where intrepid pioneers defy gravity to unlock the secrets of the universe and reshape the destiny of humanity. Brace yourself for a mind-blowing adventure into a realm where science fiction becomes reality and the infinite riches of the cosmos lie within our grasp. Get ready to witness the birth of a new era, where the stars themselves become the gold mines of tomorrow. Asteroids are a class of small rocky and metallic bodies orbiting the Sun. These bodies represent the remains of failed planetesimals or protoplanets, Aspog, 2003, and Binzel and Barucci, 1991. Asteroid composition varies widely, from volatile-rich bodies to metallic bodies with high concentrations of rare metals such as gold, silver, and platinum, in addition to more common elements such as iron and nickel. Platinum-rich asteroids. Platinum-rich asteroids may contain grades of up to 100 grams per ton, 10 to 20 times higher than open-pit platinum mines in South Africa. Saunter, 2006. These ore grades mean that one 500-meter-wide platinum-rich asteroid could contain nearly 175 times the annual global platinum output, or 1.5 times the known world reserves of platinum group metals. Asteroid composition, 2012. Asteroid mining is a proposed approach to mining critical elements from these small bodies. Because of the difficult nature inherent to mining asteroids, few companies or governments are currently considering asteroid mining. At present, only one company, Planetary Resources, is conducting research into the technologies and strategies necessary to make asteroid mining economical. Our current understanding of asteroid composition confirms they are a likely source of many critical elements, such as the platinum group elements. However, asteroid mining is currently only viable as a long-term solution. Currently, the infrastructure and techniques needed to mine and refine asteroid resources are under development, making short-term returns unlikely for mining companies. Details. Asteroid mining shows promise as a method for obtaining critical elements. The asteroid belt in our solar system contains 8% metal-rich, N-type asteroids and 75% volatile-rich carbonaceous, C-type asteroids. Asteroid belt, 2010. The denser metals in asteroids, including platinum group minerals and OREs, are distributed relatively evenly throughout the asteroid body, simplifying the mining process as drilling can be relatively shallow and not into the core for ore grades to be surprisingly high. At present, asteroid mining is a highly speculative technique. The research and technology to successfully exploit these mineral resources are still under development. Challenges include the categorization and identification of mineable deposits, building the infrastructure to mine and refine asteroid material, and creating the ability to move mined material onto Earth. Current proposals suggest placing processing facilities on Earth or lunar orbit with regular access serviced to the asteroid belt. Tomaswick, 2012. The remoteness of these facilities will make them difficult to create and maintain, requiring significant advances in robotic technology. Asteroid mining is a technology in its earliest stages with massive startup costs. Other sources of strategic elements may be discovered, and alternative technologies may reduce demand before asteroid mining becomes a reliable source of strategic elements. Cost. According to the KISS study, the cost for a future mission to identify and return a 500-ton asteroid to low Earth orbit is USD 2.6 billion, ignoring the costs to develop the infrastructure necessary to process the materials in the asteroid. Asteroid usage, 2012. However, Planetary Resources estimates that a single 30-meter-long platinum-rich asteroid could contain $25 to USD 50 billion worth of platinum at today's prices. Klotz, 2012. Once the proper infrastructure is in place, there is potential for a significant profit. Currently, research into the feasibility of human and robotic missions to asteroids is being conducted by both governmental organizations, JAXA, NASA, and private companies, Planetary Resources. Potential commercial drivers for space industrialization. The industrialization and settlement of space are likely to be brought about primarily by increasing commercial activities in space, including the following: expansion of trunkline communications, direct broadcast TV, navigation, remote sensing, and meteorological services, worth several $billions per year from an in-space satellite assets investment estimated to be about $50 billion. LEO satellite constellations will roughly double the annual income of these services over the next decade. Commercial space-based production of high-value pharmaceuticals, semiconductors, ultra-pure crystals, and exotic alloys. Although research work has been done on Mir in orbit since 1986, commercialization has been severely delayed by the loss of access to the space shuttle after the Challenger disaster. The concept of satellite solar power stations, SSPS, is again receiving active consideration after a decade of disinterest. The Japanese are planning an equatorial orbit SSPS pilot plant titled SPS-2000, orbiting at 1,100 kilometers altitude of mass 200 tons. The accessibility and competitiveness of non-terrestrial resources. The natural resources in space include metallic nickel-iron alloy, silicate minerals, hydrated minerals, bituminous material, and various volatiles, including water, ammonia, carbon dioxide, methane, and others. These have all been identified either in meteorites or spectroscopically in asteroids and comets. Any industrial development in space requiring more than about 1,000 tons of structural mass or propellant per year will direct attention to these materials as ores in the true mining engineering sense. Raw materials retrieved from non-terrestrial sources need not attract the high air freight costs referred to above. This is because the energy required to return material from many of the possible target near-Earth asteroids is much less than the energy required to launch from Earth. In addition, the freedom to deliver the velocity change non-impulsively means that low-power propulsion systems may be considered, and this allows a system that uses solar power and derives its return journey propellant from the target body, such as asteroidal volatiles. The benefits of asteroid mining. Asteroid mining offers numerous benefits that have the potential to revolutionize space exploration and benefit humanity as a whole. First and foremost, the abundance of resources found in asteroids could alleviate resource scarcity on Earth. These celestial bodies contain valuable minerals such as platinum, gold, and rare earth elements, which are crucial for various industries, including electronics, manufacturing, and renewable energy. By tapping into these resources, we can reduce our dependence on limited terrestrial reserves and ensure a sustainable supply for future generations. Additionally, asteroid mining can contribute to the advancement of space exploration by providing essential materials for constructing habitats, spacecraft, and infrastructure in space. This would enable longer duration missions, facilitate the establishment of permanent settlements, and ultimately pave the way for human colonization of other celestial bodies. Moreover, asteroid mining holds the potential for scientific discoveries and insights into the formation and evolution of our solar system. The extraction of samples from asteroids can provide researchers with invaluable data about the composition of these celestial bodies, shedding light on fundamental questions about the origins of life and the universe. Overall, asteroid mining presents a remarkable opportunity to address resource scarcity, drive space exploration, and expand our knowledge of the cosmos, offering immense benefits for the future of humanity. As we gaze into the infinite expanse of the cosmos, the concept of asteroid mining takes us on an extraordinary journey of possibilities. It's a vision where we transcend the boundaries of our blue planet and venture into the depths of space, harnessing the untapped riches of the universe. The idea of extracting precious resources from celestial bodies not only ignites our imagination, but also holds the potential to reshape our future. It's a tantalizing glimpse into a world where scarcity gives way to abundance, where humanity conquers new frontiers, and where the mysteries of the cosmos are unlocked, one asteroid at a time. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.